Welcome to clickmyproject.com. Next we discuss about the project Optimal Selection Based Suppressed Fuzzy Siemens Clustering Algorithm with Self-Tuning Non-Local Spatial Information for Image Segmentation. Let me discuss about the abstract of the project. The system proposes a modified suppressed FCM with spatial information. The membership function is modified by an optimal selection based suppressed method. The self-tuning non-local spatial information is used. A gray level histogram is constructed by using the proposed spatial information. The experiments on noisy images demonstrate the superiority of the proposed method based on the concept of machine learning with the capability of learning to improve the performance of a task. On the basis of the previous experience, we propose an OSFCM SNLS algorithm that performs clustering and selects the parameter as in SFCM simultaneously. The learning process of it is based on an exponential separation strength between clusters and is updated at each iteration. Numerical examples will serve to illustrate the effectiveness of the proposed MSFCM with the ability of performing clustering and also selecting the parameter with the prototype driven learning. Finally, we use a MSFCM algorithm to an MRI segmentation. In ophthalmology, in the proposed algorithm, every point of the data set has a weight in relation to every cluster. Therefore, this weight permits to have a better classification, especially in the case of noise data. The proposed algorithm is applied to both artificial synthesized image and real image. Segmentation results demonstrate that the presented algorithm performs more robust to noise than the standard FCM algorithm. To overcome two drawbacks of SFCM, this paper proposes an optimal selection-based suppressed fuzzy Siemens clustering algorithm with self-tuning non-local spatial information for image segmentation. By using an efficient denoising algorithm, the input noisy medical image is first denoised so as to improve its robustness. Further, the integration of spatial information into the conventional OSFCM SNLS takes longer time to converge, as well as there are lots of possibilities to converge in the local minimum. As a result, in the presented approach to evaluate local minima, the parameters of the OSFCM SNLS algorithm are initialized using histogram. Comparing to the conventional OSFCM SNLS, the histogram-based OSFCM SNLS converges very swiftly. The employed denoising algorithm and the integrated spatial information have increased the robustness of the proposed approach against noise. The experimental results demonstrate the robustness and efficiency of the proposed segmentation approach. In addition, a comparative analysis is made between the conventional OSFCM SNLS, our earlier work, and the proposed segmentation approach. Let me discuss about the flow diagram for our process. First, capture the input image from the dataset folder. Here we need to take the input image for segmentation. Next, in the image pre-processing. Pre-processing is the process of removing the noise in the image. Noise removal is nothing but the removing the noise as well as smoothing the image using filters. The commonly and effective filter for noise removal is Gaussian filter. Hence, the Gaussian filter is used to remove the noise from an image. Next, in the noise added stage, we have added the noise in the pre-processed result. In this module, we have to add the noise to the input image to transform the image into another domain, using different noise technique to be added to the input frames, such as salt and pepper and speckle noise also. Give certain levels of noise level from build the noise images easily for the future steps at this project. In order to adding the noise manually by using the fspecial function, we need to add the Gaussian noise to our images. Next, in the gray level histogram. Gray level histogram. In the gray level histogram of an image represents the distribution of the pixels in the image over the gray level scale. It can be visualized as if each pixel is placed in a bin corresponding to the color intensity of that pixel. All of the pixels in each bin are then added up and displayed on a graph. This graph is the histogram of the image. The frequencies of all the intensity levels can be seen and the image can be analyzed based on this. Finally, the OSFCM SNLS algorithm are proposed for our gray level histogrammed image. This OSFCM SNLS algorithm, most of them occur performed in the noise image. In the segmentation result of SFCM, most of noise in the image background is removed, but most of the noise in the region of image is still retained. The segmentation results of enhanced FCM and FGFCM are much better than those of the two former methods, but some noise pixels are still existed in the region of images. In contrast, the image noise is removed cleanly in the result of OSFCM SNLS. It is obvious that OSFCM SNLS obtains the best visual effect among all the methods. Let me discuss about the running procedure for our process. Select the main.temp file in the current folder, right-click that file and run for executing this process. This is the main window for the optimal selection based suppressed fuzzy image clustering algorithm. By pressing the input image button, we can browse the input image from the dataset folder. Select any one images from the dataset folder. Here I display the input image in the access one plot. By pressing the preprocess button, we need to preprocess our input image. That is removal of noise from the image. Here I display the preprocessed result. By pressing the noise image button, we manually add the noise with the help of F special function by adding the impulse or salt and pepper noise. Here I display the noise image in axis 3 plot. By pressing the gray level histogram, we extract the histogram feature values. Here I displayed in the table format. With the help of histogram feature values, we need to segment our input image by using the OSFCM SNLS algorithm. This algorithm performs the segmentation process. Here we segment the input image. That is, we extract the background and we displayed only the region which we need to represent. And this is the analysis graph between SFCM and also our proposed system OSFCM SNLS. And this graph represents for accuracy, and this represents for sensitivity, and this represents for specificity. Finally, we have presented a robust and effective approach for the segmentation of images corrupted by noise. For the segmentation of noise image, the proposed approach utilized a histogram-based optimal selection-based suppressed fuzzy image clustering algorithm. Thank you.